large language models. So we're seeing those already in our phones, we're seeing them on our computers, we're seeing them answer questions in a way that sounds like a human being.
Firstly, AI could be looking to replace work that clients would pay for. Now, is that right? I mean, with that logic, you could think back to when calculators were invented.
Welcome to the Society of the Environment EnvCast, where we feature special guests highlighting an environment top 5 each month. Each month, we welcome 2 environmental professionals to explore what they believe to be the top 5 things to consider within a particular topic. Topics range from climate to leadership, agriculture to AI, and everything in between. Look out for some curveballs in the top 5 each month, and remember, we can't cover every important thing within a topic. Our aim is to uncover how you can be part of the solution, to learn from the experts, and to sometimes think outside of the box as we strive for a sustainable future. Enjoy the episode.
Hello, and welcome back to EnvCast for another Environment Top 5, this time focusing on AI. I'm Sophie from the Society for the Environment and your podcast host for today. As always, we will be picking the brains of registered environmental professionals and exploring key topics from different perspectives to expand our collective knowledge and make more impact. Today, we are setting the scene and giving you an insight into artificial intelligence with the help of our 2 guests today. We're joined by 2 incredible chartered environmentalists. Their biographies are in the podcast descriptions. But as an extremely short introduction, I'm pleased to be joined by Astrid Wynne, who is a chartered environmentalist via their membership of the Institute of Environmental Management and Assessment, or IEMA for short. Astrid is Head of Sustainability, AI and Automation at Techbuyer, and Dominic Walkling, a chartered environmentalist also via their membership of the Institute of Environmental Management and Assessment, IEMA. Dominic is Associate Director at Nature Positive. A warm welcome to the both of you. Thank you for joining me.
Thanks. Nice to be here.
Well, thanks, Sophie.
So let's get straight into the top 5. We will alternate between Astrid and Dominic for the first 4, and the final item is for them to collaborate on the key takeaway and provide some AI guidance for our listeners. So, subtopic number 1. I think the best place for us to begin is to set the scene with some foundational context about AI. So I'm going to hand over to Astrid, if that's all right, to define AI in some practical terms and give us an insight into how AI is being applied within environmental sectors today. But first, could you tell us a little bit about yourself and your role as well?
Thanks, Sophie. My name's Astrid, as you've already said. I work for a company that specialises in the refurbishment of data centre equipment, so that's servers, storage and networking. And for a long time, myself and the team around me have been looking at energy efficiency on servers and within data centres and how you measure that. We've used various software tools to do that. I worked with a future leader fellow who was looking at digital twin for data centres, which is more about integrating models and telemetry. But he also worked on some AI projects at the company looking at machine vision and how we could use the machine vision to read barcodes at a faster rate using an element of automation in the company. So that's kind of my background. And my specialty is marrying circular economy, measurements, and practices with energy efficiency, because there's a tension on that in the digital world. Because as the generations go along, they tend to become more energy efficient. But then at the same time, you've got a huge turnover in material resources, largely unrecyclable at scale, recovering all the elements. So there's a lot of work to do on looking at that, and that's my area of interest. So when it comes to AI, as I'm sure everybody already knows, AI is a fast developing technology, and we're not actually absolutely sure what it's going to bring for us. We do know that it's a move on from machine learning. And in simple terms, we're moving from a state where we tell the machine what to learn and what outputs we want into a stage where the algorithms can do that for themselves. And it becomes more like deep learning. So it takes elements from the outside world and uses that to make assessments and judgment calls, in simple terms, on what's going on around it. And the feed for that can be from multiple locations. So the obvious, most famous example of AI is large language models. So we're seeing those already in our phones, we're seeing them on our computers, we're seeing them answer questions in a way that sounds like a human being. And that's down to analysis of tokens and syntax and mood and training itself on how to do that. And we're also seeing AI generate videos and pictures for us. They're the kind of the front level interface for most people in the public, because we're seeing that, we're playing with it. There's a whole lot of other functionality in AI that is a little bit less famous. So that's robots using sensors, vision analysis to perform higher value tasks for us rather than those repetitive tasks. You could potentially train a robot to do more complex tasks and also interact with human beings. So they become cooperative robots, or cobots is what they're called. All of that means that there are lots of applications that we can see as a viable near future when it comes to sustainability. So for a long time, people have been talking about smart farming as an application of AI. As you're probably aware, harvesting, for example, are inefficient at the moment because we just have a few days a year where we strip everything off the plants. Anything that doesn't make the grade goes to waste. If you had smart harvesting, you could have cobots do that continuously as things became ripe. Another application that I love is weeding, because I hate weeding. If you could have cobots or robots do that for you in real time, then you wouldn't turn around and 2 weeks later your vegetable patch is a mess of nettles. That wouldn't happen. So there's that. For a long time, people have been talking about digital technologies being an enabler for renewable energy. Because as we're all aware, renewable energy is not 24/7 because it's weather dependent. If you could design a system that would take that into account with weather predictions and then flick between sources in an integrated energy management system, you would have a solution on that. There are other applications that we're already seeing in smart design. So people have got AI to design chips in a more efficient way, which means that you're using less materials and it becomes more energy efficient. So the AI models are going to be really good at taking huge data sets that a human being could not possibly hope to interpret all at once and crunching that all together and then generating something useful at the end, as long as they're trained properly and as long as you've got human beings saying, correlation does not equal causation, Mr. AI bot. If you tell me when people are buying mobile phones, I can agree that time of day and weather probably has an effect on whether somebody goes into the shopping centre. Whether they're wearing pink or not is completely irrelevant. It's just something that you've picked up. So that human in the loop, trying to pull the AI model back from mistakes before it really goes down that rabbit hole, is all really useful. So that should give you an overview as far as I understand it.
That's so insightful. There's so many operations and systems already out there, like you've mentioned, and it's really interesting to see that grow over time. Do you think there's any misconceptions around AI's role within sustainability?
Yeah. I think there's two misconceptions. One is that we're all doomed, and the other is that we're heading towards a utopia. And you see that, both sides of that coming out. It's all right, we'll just get AI to do it. It's going to solve all our problems. Or AI is going to take all the water out of the world and we're going to be living in this nightmare, future controlled by robots, which looks halfway between Black Mirror and, Apocalypse Now. It's a tool. It's a powerful tool. It's an intensive tool when it comes to its effect on the environment. And it can do great good. So really, it's up to us as human beings to figure out how we want that tool to be used. Alongside a lot of environmentalists, it kind of breaks my heart when people are just playing with it, because it's like, this is, we need to figure out how we're going to power this as it grows. And we also need to figure out how we're going to make sure that we've got the resources, and that we'll get onto that later, potentially reusing, potentially sharing resources in order to fuel that new technology. I don't think there's any debate that it's coming. We need to be careful about how we use it. We need to be optimistic, and we need to use the capabilities of AI to try and solve some of the problems that it itself will create. Alongside other pieces of research that are out there on alternative sources of energy. So,
yeah, lots of positivity to come from there. So moving on from that, now we've got some context. The subtopic number 2 for consideration is the environmental cost of AI. So over to Dominic to introduce what the main sources of carbon emissions associated with AI systems are. But again, could you tell us a little bit about yourself and your role too?
Thanks, Sophie. So I'm an associate director at Nature Positive, and I head up the carbon team. So Nature Positive is a sustainability consultancy that specialises in climate, nature and human rights, and it's part of RSK Group, which a few people might have heard of. I want to caveat this at the top by also saying that I'm not an expert in AI, just an enthusiast, but I led a working group at RSK and Nature Positive over the last year to kind of just keep on top of this and just make sure we're doing everything right. I wanted to talk a little bit about the environmental impact of AI. So running it obviously consumes a lot of resources and the environmental impact is significant. I'll focus mainly on the electricity usage, but water is a massive part, as Astrid's already mentioned. We'll talk mainly about electricity consumption. And to start off, I wanted to just give a few statistics just for the listeners. So globally, the electricity consumption of data centers rose to 460 terawatts in 2022. So it would have made it the 11th largest electricity consumer if it were a country in the world. And then over time, this is forecast by 2026 to become the 5th place on the global list. So really, really big consumer of electricity for sure. Important to note that it's not all generative AI, but that has driven the demand a lot. Some research suggests that it's about 1/5 of the overall energy demand on data centers is AI, but that's forecast to grow. Also, really important for us to think about the life cycle of AI too. So not necessarily the hardware, which Astrid's going to get onto in a bit, but mainly talking about the training of AI models. So at the moment, they typically have a really short shelf life, driven by demand for new AI applications. So all of the energy that goes into training those systems originally then goes to waste as soon as they're replaced. So another statistic, just to give some context, ChatGPT training process consumed around 1,200 megawatt hours of electricity. So that's enough to power 120 average US homes for a year. So really important to think about that. Also important to say that overall AI companies aren't necessarily the most forthcoming with the amount of energy that they're consuming and their carbon emissions data. So that's quite hard to look into. But a few researchers have suggested that a ChatGPT query consumes around 5 to 10 times more electricity than a simple web search. So that's alluding to the point Astrid mentioned around just using this for what we need to use it for. So the carbon impact of these data centers is dictated by the region in which the energy is consumed. and the percentage of the renewables in the grids where they are operating. So in 2022, Google operated its data center in Finland on 97% carbon-free energy, but then their data center in Asia was operated on 4 to 18% renewable energy. So it's really important where they're located in the world. So these companies have a lot of purchasing power in terms of renewables, but it's projected that the growth of AI is going to outstrip the renewables that are actually available to power them. So that is important to consider. Final point on that is that the complexity in the AI models that are being used directly correlates the amount of energy they consume. So image generation is one example where AI is using a lot of energy intensive versus perhaps a simple web search or just processing a little bit of data. So I want to talk a little bit to some of the solutions of reducing this impact, the carbon impact of AI, which is what is called green in AI. So one solution that has been mentioned is what's called equitable aware geographical load balancing. It's really wordy, but it essentially means using locations that are greener and have water resources available to do the processing of data and providing the energy to these data centers. So essentially moving where the work is done by AI to places where there is surplus energy. So apparently this is quite easy to do, but again, I'm not an expert in AI to say how easy specifically, but some of the papers suggest that it is easy. Underwater data centers is another topic that's been floated because obviously it's cool underwater, but then the biodiversity impact of this is also something that needs to be considered. Building data centers in cool climates is really important too. So obviously they don't need as much cooling then. And then a few more novel things that I've read about are space-based data centers, bioengineering and quantum computing, but none of those are quite there yet in terms of usability. Finally, and Astrid touched on this a little bit, but how can AI help us in terms of sustainability topics? So this is called Green by AI. So what's AI going to do for us? So a few applications are smart mobility, so mapping traffic in cities for optimization, doing precision farming, recognition for species monitoring, or mapping deforestation, reforestation. The list is endless for all the things it can do. There is also a lot of excess heat generated by data centers, so this could be used as a kind of side benefit of running those data centers. The next thing I will say is that it can help sustainability consultants work more efficiently, which is why a lot of people are listening to this podcast in the first place. So it is projected that generative AI produces less carbon emissions compared to a human performing the same task, up to 300 to 3,000 times fewer emissions. Obviously, that's a broad range, and it depends on the task, but it is a really important fact to consider.
Seems to be a lot packed in there, Dominic. Astrid, did you have anything else to add into that at all?
No, not really. I think it's all super interesting. I think that the point around lack of transparency is an important one. MIT have just released a report on the energy impact of AI, talking to multiple researchers. One of the big headlines of the report is that all the modelling that takes place is on OpenAI models, which tend to be a lot smaller than the proprietary models that are on the market. So they're looking at indications and they're extrapolating from those indications. And it would be really helpful if the larger suppliers came out and were a bit more open about what was actually happening, because then we could get somewhere with measuring and improvements. And also on heat reuse and location of data centers, I think that's really important as well. I work a little bit with the Data Center Alliance in the UK, and one of their priorities, I guess, is to extend the variability of data center locations. So a lot of the builds are projected or encouraged in areas where there are already data centers, and there are areas under water stress and potentially energy stresses as the AI issue grows. If you take them out into unexplored areas like the west coast of Scotland, you probably have a better solution because you've got more wind energy produced by that particular area of Scotland than is being used. So you've got a surplus in supply there. So I think rethinking location is probably something that's quite useful. And it's probably something that the environmental sector can really help with. Identify areas that would be potentially useful and also identify co-benefits alongside that, like increased connectivity, like outreach, like potentially, food growth, that whole reusing heat potentially for greenhouses might be a good idea, because then we wouldn't have to fly in vegetables from all over the world, and we would be able to transition towards a more plant-based diet. And there might be other co-benefits that you could achieve by doing that.
Yeah, it seems like there's a lot of benefits that could come from this.
It's all about systems thinking, isn't it? It's all about, which again, environmentalists tend to do quite well. What is the wider impact of doing this? That's how environmentalists are trained, is to think about multiple things at once and the best solution on all of those metrics.
Exactly. And that's what they do best. So moving on to subtopic 3, which is, of course, back to Astrid. And this time we're highlighting materials and the life cycle aspects of AI infrastructure. Sounds amazing.
It is amazing. It's also uncharted, largely. I worked on a project called the Circular Economy for the Data Center Industry project, which ran over 4 years and covered 7 countries in Northwest Europe, and it was Interreg funded. The reason I'm telling you all this is to kind of give you an idea of size and scope of that project. That project did a lot when it came to analysing, for example, what's in servers, but it had to do that from first principles because of the way that the supply chain works for IT hardware. So if you go to the information from the manufacturers, they then need to go out to the information from their component suppliers. The component suppliers often don't have the data, and if you look at it in the lab and you reverse engineer the equipment, which is what the project ended up doing, ended up breaking down hard disk drives, CPUs, analysing the components, and then using EcoInvent to go out to source and try and figure out what the impact on eutrophication was, water, etc., using that methodology, you find that the same make and model can be from multiple different suppliers because of the way that the industry works. So you've got small scale, small component suppliers, batch filling in the Middle East, in the Far East, and then you've got then batch filling for the equipment suppliers, and it kind of goes on like that. So the academics have described it as a spaghetti soup of a supply chain, and trying to track what the impact of that is incredibly difficult. So what they've done is they've done the typical LCA approach, which is work a little bit on averages and a little bit on assumptions, and then just be really transparent about where they've got their information from. The databases themselves are patchy because they tend to depend on what research has been done and what research has been uploaded. So there's a whole bunch of stuff there as well. So with that huge caveat, looking out through the supply chain, it tends to go on the materials, right? And when you look at what's in IT hardware at the moment, you've got pretty much every element of that table that they use in chemistry, the periodic table. So it's all over the place. And at last count, we had 23 of the critical raw materials on the EU list of 35 in server storage and networking. That's as a basis. When you look at what's happening now with the materials changes, that's going to increase because you've now got tantalum included in GPUs, for example. That will go out to the mines. So you'll have social impacts in the Democratic Republic of Congo, where some of these materials are coming from, and also in other areas of the world where the health and safety regulations are not as advanced as in the UK. You've got toxicity associated with that mining, and again, poor health and safety regulations, meaning that does go into the soil, does go into the water. Then you've got all the travel miles associated with bringing that supply into the manufacturing area of components, which it is basically China, Taiwan, and Thailand, so Southeast Asia. And then you've got all the travel miles associated with bringing that to the original equipment manufacturers for IT hardware, which are located in Europe and the US predominantly, and then out to the first user. At end of life, that all goes back in reverse. So, you go down, you're not allowed to ship waste electronic equipment, but if you send it to your recyclers, you're not sure where those materials go. So you've kind of got this, travel mile impact in reverse as it all goes back out. And that's just what's happening now. So when you look at what's happening with AI, you've got these generations that potentially you could harvest components and then reuse them in new systems. That's not going to be the same as it has been until now, because the hardware itself is changing. So a big change will be the processors moving from CPUs, which are fairly well understood and supported by memory, into things like GPUs, and then other specialized chips that carry out particular workloads. When you change that, you change the entire supporting system underneath it. So you can't just swap out a CPU for a GPU. You have to have a GPU served by CPUs, served by all this, that, and the other. The impact on electronic waste is likely to be significant. Let's just put it that way. There will be figures flying around on there. I haven't researched those because I'm not sure they're true, because I'm not sure that we have the data to actually stand by those figures, but the impact is going to be large. So given the fact that we know that this will cause land change impact with the mining, it'll cause deforestation, it'll cause toxicity, it'll cause a huge impact on water availability. And it'll also increase resource scarcity, which links to conflict and other issues around that. We know that we're going to have to think fast and think creatively about what we're going to do with these new systems. The obvious one is circular economy. That is the obvious place that we need to be heading towards. And maybe we could get AI to give us a hand in designing that circular economy, because it's great, a huge sets of data points. And maybe it could also analyze its own impact, because it could crunch all those figures that we don't have available, and we could feed it in the lab with materials information. Circular economy, what I mean by that is obviously the IT hardware itself. So recycling technologies need to develop. They need to develop fast. They need to be funded. We also need to pour funding into the use of recovered materials. So if you look at the strategies around circular economy, they tend to rely on, okay, let's keep things in country so that we're not at risk in the supply chain, which is sensible. Let's also fund recycling technologies to recover these materials at scale and figure out how we make that economically viable. That needs to happen. What's missing is you don't have research being carried out into what the quality of these recovered materials are. We need to do that, and we need to do that fast, and we need to integrate it into the design stage of our electronic equipment. But it also goes out much further than that. And Dominic's already talked about heat reuse. That is a really, really useful thing that we could be doing with this new technology. So a rough estimate, being safe, 99% of the electricity that goes into data centers goes to heat. A rough estimate, and 1% goes to compute. Now, this is well known in the data center sector, and that's why the whole concept of heat reuse was born, because engineers can see this as a waste. Now, the issues around heat reuse at the moment tend to be that you've got quite low value heat coming out of the data centers. So it needs to be boosted by other systems to make it usable for district heating or water in swimming pools or some of the other great uses that you've got on it. Greenhouses, just saying, just want vegetables all year round, that'd be good. But the good thing about AI is it's generating a higher heat. Now, that can be a risk on one side. It can also be a massive opportunity if you start looking at it in the right way. Because if you've got higher grade heat going into your systems, then you can potentially design out some of the other heat generating, energy absorbing technologies that we've got out there. Other use cases is that you're bringing connectivity and you're facilitating some of the benefits of AI in remote areas. So as Dominic was saying, there's all this smart farming. Realistically, are you going to be able to smart farm in remote, disadvantaged areas? Possibly not, because you don't have the technology and you don't have the money to provide the technology. If you can use your data generation and your electricity generation and capture that heat and capture that energy and also capture that connectivity in direct proximity to your user, you've got a much better chance of having those benefits from AI in remote areas. So it's about systems thinking. It's about integration. It's about conversations on co-benefits that we can have right now with local and national government. And it's about being creative and seeing opportunities and co-benefits instead of just risk that we have to get rid of. Yeah.
I feel like that could be a whole podcast by itself. There's so much to unpack in there. And there's just so much detail. But I think we're going to move on to subtopic 4. And this is another big topic that could probably be another podcast by itself. But we're going to look at ethics of using AI. So I'm going to hand over to Dominic to surface some of those concerns and responsibilities around the AI deployment. So over to Dominic.
Yeah, thanks, Sophie. Yeah, it's definitely a massive subject and one that I'm not going to claim to have all the answers to, nor if I thought I had an answer, I probably wouldn't say on a podcast. So I'll go through the stuff that I've read about, and hopefully it will spark some thoughts from the listeners. The first ethical subject that we could talk about is the environmental impact that we've discussed to death at the moment. So what, firstly, is it worthwhile using all of this energy for? We need to be making sure that we're not wasting it. That's the first ethical subject. But I think one of the other main ethical issues around AI is because it looks to replace the work that people do as their jobs or day to day. So in practical terms, firstly, AI could be looking to replace work that clients would pay for. Now, is that right? I mean, with that logic, you could think back to when calculators were invented and accountants started using them. I mean, would you as a customer want to pay more for an accountant not using a calculator? But surely when they first came out, you'd want to know that they were using the tool. So perhaps disclosure of usage is the key. And this is something that we've seen pop up in proposals and bids that have come our way. What are you using AI for? It's not say that you're not going to use it, but it's saying just disclose up front what you're using it for. Another ethical issue is that AI could be used to replace entry-level roles or just tasks that junior members of staff might have originally used to train up on. So this could be things like transcribing or market research or just doing repetitive tasks. I think it's inevitable, but I don't think it's a game changer. I think that there are plenty of other roles, and we need to adapt our businesses to make sure that we're still providing opportunities for junior staff to learn, and that is the role of managers. But equally, large language models like ChatGPT can be used to help with training. So especially if you're talking about a scientific subject which has fixed parameters, you can use ChatGPT or another model like a chatbot, and there's no silly questions. You could just ask 100 questions in a row, explain it this way, explain it that way, and it is a really useful tool for that. Another thing to be aware of, slight ethical stance, is that that a lot of these large language models have biases because they were trained on data that is publicly available on the internet. The internet is in itself biased. So you've got a lot of westernized content, you've got political slants, there's stereotyping. So there's all these things that you have to be really conscious of when using ChatGPT or Gemini or whatever other model you're using. Governance is a separate topic and a massive one as well. And as it is within the roles of the businesses to control this, but also large governments as well. So firstly, day-to-day use, we need to be sure that the data that we're inputting into these models is secure. So we don't want to be using client confidential data and uploading it that's then going to be used to retrain the model. We need to make sure that the data we're uploading, if any, is either not confidential or completely secure. Slightly stepping away from day-to-day work, we need to be thinking about what is right or wrong to use AI for. So I want to go into art and entertainment because it is a contentious subject, but important to touch on ethics. So a few rhetorical questions. So we know that AI has been used in films, for example, to de-age actors, and this is with their consent. Like, is that right? They have consent, so you could argue it is. But then what about to recreate songs of artists that aren't around anymore? It's definitely been used for that as well. And perhaps those artists wouldn't have known AI was going to be invented. So that's something to think about too. Then what about original creation? If you think about writing scripts and writing stories, it can be used for that, but that was the whole cause or big part of the writer strikes in LA over the last few years. So really, really important to think about all those subjects. But in taking it back to the environment, we need to be keeping in mind that the things that AI is used for is worthwhile and is worth the environmental impact that we're talking about, and is not just being used for needless tasks. We're probably remiss to not mention unethical things that AI can be used for as well that we need to be aware of. So deepfakes is one of the big subjects. So creating fake videos to implicate people for things they haven't done or influence politics, and that's a whole other area that you could go into. You could argue that we should be looking to governments to regulate this, and the USA was leading on a lot of this stuff until recently. And that's something that we need to be aware of. That the AI companies aren't going to be necessarily self-regulating themselves. It's not in their interest to hamper development. So definitely need to be aware of that. But what companies can do, so sustainability consultancies listening, is to create AI panels or working groups of people that are interested in this stuff to keep on top of regulations and make sure that the companies are agreeing set positions on what they should be doing and what they should be using AI for, making sure everyone's aware of all of these limitations.
I think that's a good point to end on as well. A nice way to keep people accountable. So I think we're covering so many great things in this episode so far. And we're on the final topic, which is crazy. This has gone so fast. And the final item is for both Astrid and Dominic to kind of bring out the key takeaway. What should environmental professionals consider before adopting AI tools?
All of the above. I really liked what Dominic was saying about the working groups. I think that's a really useful thing for any company to have, because it is new technology and you need to examine it carefully before you start using it. Like, first of all, how we use it and how it's going to be useful, because everybody's going to have a different view on that. And also what we need to be aware of, and everybody's going to have a different view on that. And I think that whole discussive approach is massively useful when you're looking at something, so that you don't make a knee-jerk reaction and a load of mistakes, and also so you don't double up on usage. So if you work in a company, even quite a small company, you realise that if people are given autonomy, which is a good thing, they tend to go off and do things, and then they're doing a load of stuff in parallel, which really might be better if you joined forces and collaborated a bit more. And I think that whole collaboration aspect and perspectives is really important.
Yeah, definitely. And on the working group side of things, I mean, when we led ours last year, it was everyone on the working group didn't have any prior experience in AI. It was purely just out of interest. And there's so much content, podcasts you can listen to about this kind of stuff. So you can go and start from scratch. Any company can. But I think the main thing that we got out of it is making sure that everyone's using consistent approach. So perhaps use this platform for this task, or this one for this task, don't use this one for this task because it's not, it's going to retrain based on your data. So having those set rules is really, really important.
Yeah, and also picking up on another thing that Dominic said. I'm just going to hijack his his ideas for the was being aware of data leakage is really important. So, some IT teams will want to download their own model and stick it underneath their own firewall and make sure that there's a real strong protection between your data and how you're training that model and the rest of the outside world. I think that's useful. Also, just be a bit aware of how the models work. So one small example is that you might have a large language model built into your Office application, and you may be using it to use it for competitor analysis, for example, on other people's websites, which is a valid use, and it's going out there and it's searching the internet. If you're not aware, and if you don't shut that model down, if 2 hours later you then have that same chat open and you haven't exceeded the query amount and you're brainstorming ideas, you might inadvertently get a load of ideas from your competitors. This is a small example, which is probably not that important, but just being aware of when your model will remember things from earlier on in the chat and when it won't, what it's picking up and how it works and how you insulate yourself from that is probably a good idea. Standardized approaches, data security, and also as much understanding as possible on how things are going to work is probably a good idea.
Well, we've covered a lot today, and I trust that our listeners have found it very valuable. So thank you very much to both of our guests today for joining us. If you have any ideas of what could have been in this special AI episode, do let us know in the comments. We're keen to keep this conversation going. And finally, please check out any links and resources in the podcast description to keep on learning more about this topic. So thank you again, and we'll see you in the next episode very soon.